Good evening, students. Good afternoon. Are you guys able to hear me? Can someone confirm if you're able to hear me?
Yes, sir.
Okay. So yesterday we were discussing a concept, right? Told you it's called as lens maker's formula. Do you guys remember what it was? Just do you remember what it means? Can someone tell me what is the formula? Right. This we call it as the lens maker's formula, where 1 by f is the focal length of the material. Focal length of whom? F stands for the focal length of the lens material. See, lens need not be made up of glass always. It can be made up of some material like water. We sometimes have a transparent surface which is filled with water or oil, something like that. So if things will add to the focal length of the material is equal to mu2 divided by mu1 minus 1 into 1 by r1 minus 1 r2. So what is the value of mu2? Mu2, write it down, is the refractive index of the material. Okay. Mu1 is what? Refractive index of surrounding medium. R1 is what? It is the radius of curvature of the first surface. R2 is what? It is the radius of curvature of second surface. Okay. Please make a note of it. We'll do some 3 to 4 problems that are based on this concept. Then we'll move on to the next important topic. Okay. So am I clear to this point? So 1 by f is equal to mu2 divided by mu1 minus 1. So mu2 by mu1 is one quantity minus 1 into 1 divided by r1 minus 1 divided by r2. Okay. So with this known to us, we will try out some problems which are based on the lens maker's formula. So read the answer, read the question. The radius of curvature of each face of a biconvex lens, biconcave lens of refractive index 1.5 is 30 centimeter. I repeated. The radius of curvature of each face of the biconcave lens of refractive index 1.5 is 30 centimeter. Calculate the focal length of the lens in air. Calculate the focal length of the lens in air. So how to solve this? Can you guys try and tell me? So mu2 is how much? Mu2 is how much? Why is no one speaking?
Sir, your voice is breaking.
Is it so?
Can you repeat it again?
I'm asking what is the value of mu2? One minute.
1 point.
1.5, sir.
Yeah, that's right. 1 minute. 1 minute. 1 minute. Yeah. So now I hope my voice will be stable. 1.5 is right, guys. And what about mu1? So what is mu1?
Same 1.5.
Mu1, no, it is not 1.5. It is 1 because outside medium is air medium. Okay. And remember, it is a biconcave lens. Biconcave lens looks something like this. So if I take this as medium 1, and if I take this as the second refractive surface, the radius of curvature of the first surface will be like this. The radius of curvature of the second surface will be like this. And both are 30. But here, you need to be careful with the sign. R1 is equal to 30, no doubt in that. Is it positive or negative? Look at the diagram, you will get the idea. So here is the pole. With respect to that, take the sign convention.
Negative.
R1 is
R1 is
negative. Yes. R1 is negative and R2 is positive. So take all these values and substitute it in the formula 1 by F is equal to mu2 divided by mu1 minus 1 into 1 by R1 minus 1 by R2. Okay. Do it. Do it fast and tell me what is the answer. So mu2 divided by mu1, 1.5 divided by 1 minus 1. So 3 by 2 minus 1 is half. Half into minus 2 by R. So 2 and 2 will get cancelled. You will get minus 1 divided by R is 1 by F. Did you understand why I wrote it as minus 2 by R? Because 1 by minus R minus 1 by R. R1 and R2 both are 30 only. So F is equal to how much? It should be minus R, but minus R is 30 centimeter. Okay. So try the next one. The radius of curvature of the faces of a double convex lens are 10 and 15 centimeter. If the focal length is 12 centimeter, what is the refractive index of the glass? So what is given? Focal length is 12. So focal length of a convex lens, is it positive or negative? Focal length of a convex lens, is it positive or negative? It is positive. Have this in your mind. Okay. Similarly, R1, if I take it as 10 centimeter, R2 will be how much? 15 centimeter, but with a negative sign because this is a biconvex lens. So convex lens means this is R1 and this is R2. So R1 is positive, R2 is negative, right? So they're asking what is the refractive index of the material. Mu2 is equal to how much? And mu1 is equal to 1. Substitute all the values, find out the value and tell me what is the answer. Make it fast. So what is the answer? Guys, can we make it pretty fast? Because we have a lot of topics to be completed. Can you be little active, please? One by f is equal to mu2 divided by mu1 minus 1 into 1 by r1 minus 1 by r2. So 1 by 12 is equal to 3. We have to find the refractive index. No, the refractive index of glass minus 1 into 1 divided by r1 is plus 10 minus 1 divided by r2 is minus 15. So it becomes 1 by 15. So mu g minus 1 into 25 divided by 150 is this thing. So 25 divided by 160 means 1 by 6. So 6 will cancel 2 times. So half is equal to mu g minus 1, which implies mu g is equal to 1 plus half, which is 3 by 2 or 1.5. Okay. So that is the answer for the second one. Third, there is a biconvex lens which has a focal length 2 by 3 times the radius of curvature of either surface. A biconvex lens has a focal length of 2 by 3 times the radius of curvature of either surface. So R1 is equal to R2 is equal to R, and F is equal to 2 by 3 times R. Calculate the refractive index of the lens material. Okay, calculate the refractive index of the lens material. Let's try this out. So third question is 1 by f is equal to refractive index of glass by refractive index of air minus 1 into 2 divided by r. I'm assuming it is biconvex. There is a double convex. Sorry, biconvex lens. Yes. So 2 by r. But f is equal to how much? 2r by 3 is equal to mu minus 1. Because refractive index of glass, I call it as mu. Refractive index of air is 1 into 2 divided by r. R and r will get cancelled, which implies mu minus 1 is equal to 3 divided by 4, which implies mu is equal to 1 plus 3 by 4, which is 7 by 4. 7 by 4 is 1.75. Okay. So I'll share the sheet. You guys do it later. You don't seem to be interested to solve this. I'll go to the next concept. Yes. Write down the next heading, that is lens formula. Okay. So lens formula is basically 1 by v minus 1 by u is equal to 1 by f. Okay. Let's say this is f and this is c. This is f and this is c. Okay. So I'm taking a ray diagram like this. I keep an extended object which is beyond c. So how to complete the ray diagram for it? If I take a ray parallel to the principal axis, After refraction, where will it pass through? After refraction, it is going to pass through the focus. Now, if I take a ray through the optical center, that is going to travel undeviated, right? When that is going to be the case, then what will happen is you will get the position of the image between whom? Between the focus and the center of curvature. It is something similar to the concept of mirror, except the fact that the object and image in this scenario are on either side of it. Okay. So this is U, this is B, and this is the focal length. Okay. Now see, if I take this as AB, the center of the lens as O, and this point as M, I'll drop a perpendicular like this, and I will call this as A dash, B dash. Now listen to this. I need two sets of similar triangles. So the triangles that I'm going to take are BAO is similar to triangle B dash A dash O according to the same AA criteria, because this angle and this angle are same and two angles are 90 degrees. So the other angle is obviously going to be the same. So BAO is similar to triangle B dash A dash O. So BA divided by B dash A dash is equal to AO divided by A dash O. So what is BA? Okay, I'll write it later. This is equation number 1. What are the other two triangles that are similar? So if I see triangle MOF, this angle is 90, and here the vertically opposite angles, they both are same. So triangle MOF is similar to triangle B dash, similar to triangle B dash A dash F. So MO divided by B dash A dash is equal to OF divided by A dash F. Okay, but remember MO is mathematically equal to BA. So BA divided by B dash A dash is equal to OF divided by A dash F. So let this be equation number 2. Then here you have BA by B dash A dash. Here also you have BA by B dash A dash. So it will be something like this. AO divided by A dash O is equal to OF divided by A dash F. So what is AO? AO is minus U divided by A dash O is plus V is equal to OF is capital F divided by A dash F. So A dash F is nothing but V minus F. Okay. By cross multiplying, what you are going to get is minus UV plus UF is equal to VF. So divide with UVF on both sides. What are you going to get? Minus 1 by F plus 1 by V is equal to 1 by U, which implies take this to the other side, bring this to the other side. 1 by V minus 1 by U is equal to 1 by F. And this is what is called as lens formula. The previous one, but which we discussed, was called as lens maker's formula. This is called as lens formula. So I suggest everyone to copy it.
Done, sir.
Okay. Now listen. Magnification. So when we talk about magnification, it is defined as the ratio of size of image to size of the object. So what is size of the image? Size of the image is B dash A dash. Size of the object is BA. Okay. So B dash A dash divided by BA is equal to A dash O divided by AO. So what is it? B dash A dash divided by BA is equal to A dash O divided by AO. So which implies B dash A dash is what? Minus height of the image because it is inverted divided by BA is height of the object, that is HO, is equal to what is A dash O is capital B divided by AO is U, which implies HI divided by H naught is equal to minus V by U. No, you should get minus U. So it will become plus U. Done. So this is what is the magnification of lens. Next is power of lens. Where is it? So next concept is power of lens. So power of lens is what? It is basically going to tell you the measure of convergence or divergence which a lens introduces the light falling on it. Means power of a lens will define how good a lens can converge or diverge a ray that is falling on it. Okay. So what can you say for that? If you take a lens of shorter focal length, it bends the incident light more. Right? Logically, it is going to happen. See, if one focus is here, if I have another lens whose focus is here, if I take a ray incident parallel to the principal axis, which one will make this ray get converged more? This bend is more compared to this bend. In the sense, this angle of deviation is going to be different in both the cases. If you see, the angle of deviation is more in the case of
Second
more
case.
yes, is more in the case of second.
Shorter focal
Right?
length.
So from this, yes, because it is having shorter focal length, while converging it in the case of convex lens and diverging in the case of concave lens. So what is going to happen is power of lens is defined like this as the tangent of the angle. Tangent means tan. Okay, tangent of the angle by which it converges or diverges a beam falling on it. So if this angle is delta, if I drop a perpendicular from here, then this angle will also be delta because they are alternate interior angles. So if I take this right angle triangle, observe, then what is tan delta going to be? Tan delta is going to be h divided by f. Okay, but listen, is defined as the tangent of the angle by which it converges or diverges a beam of light falling at a unit distance from the optical center. Means the value of h should be 1. So if I take this h is equal to 1, okay, if h is equal to 1, which implies tan delta is equal to 1 by f, then this tan delta is what is called as the power. Okay, and the SI unit of power of the lens is going to be diopter. 1 diopter is equal to 1 meter inverse. So the power of lens of focal length 1 meter is of 1 diopter. Okay. And lastly, you need to have this point in your mind. Power of lens is positive for converging lens. Means if you have a convex lens, it is positive. And power of lens is negative for diverging lens. Means for a concave lens, it is negative. Suppose in the question they give you, when an optician prescribes a corrective lens of power plus 2.5 diopter, what have they suggested? They have suggested the converging lens for you. That is a convex lens. Suppose the same lens of -4 diopter is prescribed to you. Then they have suggested you a concave lens. Okay. So one important point I would like to mention here is power is equal to 1 by f. If you write it in terms, if you write focal length in terms of meter, the same power is equal to 100 divided by f if you write the focal length in terms of centimeter. Okay. So let's try this problem. You guys try this. If f is equal to 0.5 meter for a glass lens, what is the power of the lens? Power is equal to 1 divided by f, because f is given in terms of meter. So it is going to be 2 diopter. Right? Since the focal length is given positive, power will also be written in terms of positive value. So that is the first part of the question. The second part is the radii of curvature of the faces of a double convex lens are 10 centimeter and 15 centimeter, and its focal length is 12 centimeter. What is the refractive index of the glass? This we have already solved. This is the one we solved from the worksheet that I showed you. Answer came out to be 1.5. Read the third question. There is a convex lens which has 20 centimeter focal length in air. So focal length is 20 centimeter with a plus sign. What is the focal length in water? Provided the refractive index of air water is 1.33, refractive index of air glass is 1.55. So refractive index of glass with respect to air is 1.55, and refractive index of water with respect to air is going to be 1.33. So 1.5 is 3 by 2 and 1.33 is 4 by 2. So focal length is equal to plus 20 centimeter. Then what can we do? 1 by focal length in air is equal to refractive index of glass divided by refractive index of air minus 1 into into 2 divided by r. There is reason why I wrote 2 divided by r. Can someone tell me why I wrote a 2 divided by r? Because r1 is r and r2 is minus r. So when you substitute the formula 1 by r1 minus 1 by r2, here it will be r, here it will be minus r. So it will be 2 divided by r. This is the value of 1 by fa. This is equation number 1. Now what about 1 by the focal length of the glass in water medium? So that is refractive index of glass divided by refractive index of water minus 1 into 2 divided by r. Okay. Now what you do is divide both. When you divide both, focal length in water divided by the focal length in air will be equal to refractive index of glass with respect to air is 3 by 2. So 3 by 2 minus 1 is half divided by mu g is 3 by 2 divided by mu w is 4 by 3 minus 1 into 2 by r. So 2 by r, 2 by r will get cancelled. Fw divided by Fa is equal to half divided by 9 by 8 minus 1, that is 1 by 8. So this will cancel it 4 times. So 4 by 1 focal length of water will be 4 into focal length in air. That is going to be 4 into 20, which is 80 centimeter. And make a note of it. Done. So the next
Yes,
concept is combination of thin lengths in contact. So now we are going to see what is going to happen when you put two thin lengths in contact with each other and try to calculate their focal length. Okay. So the heading is combination of thin lenses in contact. So if suppose you consider two lengths A and B of focal length f1 and f2 placed in contact with each other. Okay, they are placed in contact with each other. There is an object which is placed at O beyond the focus of the first lens. Okay. So it is placed somewhere over here. Then what will happen is this ray will go travel like this, right? And it will bend in such a way that due to the first lens, it should have formed an image at point I1. But what is happening is it undergoes a second refraction, and due to which it goes and hits the surface, and the final image is formed at this point. So why I'm saying its final image is because one of the rays we would have considered is through the optical center. So through the optical center, the ray will travel without any deviation. Right. So this is where the final image is formed. This concept is something similar to what we discussed in the lens makers formula, the derivation of lens makers formula. I hope I'm clear till this time. Right.
yes,
Good. So now see, if I take the object distance as u and the image distance from the first lens as v1, then the final image distance from the second lens as v, then in the case number 1, due to the first lens, if I apply the lens formula, 1 by v minus 1 by u is equal to 1 by f. Look at the way I'm going to write it. I will write it as 1 by v1 because that is the final image. That is the image distance with respect to object lens number 1 minus 1 by u is equal to 1 divided by f, which is f1, because the focal length of the first lens is taken as f1. Okay, this is 1. So in case number 2, what is going to happen? 1 by v is v only, minus 1 by v1 is equal to 1 by f. Why did I write 1 by v1? Because that is the object distance with respect to the second lens. Now what you do, add equation 1 and 2. Then what will you get? 1 by v minus 1 by u is equal to 1 by f1 plus 1 by f. Accepted? Now see, this 1 by v minus 1 by u is there, right? So I have two lens. So two lens has these two lenses have individual focal length of f1 and f2 respectively. Now, if I replace these two lenses with one particular lens whose equivalent focal length is f, then 1 by v, that is a 1 by the final position formed due to the combination, minus 1 by u will be equal to 1 by f, right? So what I'm trying to say is this 1 by u, v minus 1 by u is called as the effective focal length. Means if I replace those two lengths with one particular length whose focal length is effective, then this would have been the mathematical relation. So 1 by f effective is equal to 1 by f1 plus 1 by f2. But what is 1 by f effective? It is the effective power is equal to 1 by f1 is p1 and 1 by f2 is p2. So to put it in simple terms, if the lens are kept in contact with each other and you know the focal length of each lens, then you need to calculate the effective power of it by adding the individual powers of all the lens put together with proper sign convention. With proper sign convention. Okay. Is it clear till this step?
Yes, sir.
Yes, you can handle problems, right? If it is asked. Now, the next question is what is going to be the effective magnification? So, magnification due to the first lens is going to be how much? It is going to be V1 divided by U. What will be the magnification due to the second lens? It will be V divided by V1. Right? What will be the magnification due to the combination? It will be V divided by U. Because final image divided by the object distance. So V divided by U is there. Means can I write it as V divided by V1 into V1 divided by U? But what is V by V1? It is M1 and V1 by U is, sorry, V by V1 is M2 into V1 by U1 is M1. So what is happening to the effective magnification? The effective magnification will get multiplied. So three important points that we have understood is the reciprocal of focal length will be equal to the sum of the reciprocals of the individual focal length with proper sign convention. Similarly, the effective power is equal to the sum of the powers of individual lenses with with sign convention. Similarly, magnification will be the product of first and second device. Okay. So this type of combination of lenses is commonly used in designing lenses for cameras, microscope, telescope, and other optical instruments because those devices will have the tendency to magnify the object more. Okay. Right. So next concept that we are supposed to discuss is refraction through prism. After that, this eye concept is not there. Then we will go to the optical instruments part. Let's try this problem. Okay. Find the position of the image formed by the lens combination given in the figure. So there is an object kept in front of a convex lens whose focal length is 10 centimeter, and the object is placed at a distance of 30 centimeter. Okay. in between two convex lenses, there is a concave lens which is kept at a distance of 5 centimeter from the first convex lens and at a distance of 10 centimeter from the second convex lens. Okay. Now we need to find where the final position of the image is formed. So let's calculate the image distance with respect to the first object, first lens. For first lens, 1 by V1 minus 1 by U is equal to 1 by F, or 1 by U1 is equal to 1 by F1. So V1 is unknown, minus 1 by U1 is minus 30 is equal to 1 divided by F1 is plus 10. So 1 divided by V1 is equal to 1 by 10 minus 1 by 30. So 30 minus 10 divided by 30 is 20 divided by 300. This will cancel. It will go 15 times. So V1 is formed at a distance of 15 centimeter, means it is exactly formed at the optical center of whom? It's formed at the optical center of the third lens. Okay. Now, this 15 centimeter will act as, so 15 centimeter is the distance from the first lens. So how much is the distance from the second lens? The distance is 10 centimeter. Now this 10 centimeter will be the object distance with respect to the second lens. So with respect to second lens, 1 by V2 minus 1 by U2 is equal to 1 by F2. So 1 by V2 minus 1 by U2 is how much? It is 10, is equal to 1 by F2 is minus 10. So this and this will get cancelled. V2 will be at infinity. Right? V2 will be at infinity. So when V2 is at infinity, guys, did you understand till this step?
Yes, sir.
Okay. When V2 is at infinity, means the image due to the second lens is formed at infinity. So with respect to the third lens, where is the object placed?
At
With
infinite.
at infinity, right? So when an object is placed at infinity, where is the image formed? This is a known theory. Object is kept at infinity means rays are parallel to the principal axis. So where is the image formed?
Focus.
Focus. So the image will be formed at the focal point of the third device. So the answer is final image is formed at plus 30 centimeter. It's very simple, right? 1 by V3 minus 1 by U3 is equal to 1 by F3. 1 by V3 minus 1 by U3 is infinity is equal to 1 by F3 is 30. So V3 will be equal to 30 centimeters. That's it. So the image is formed on the right of the third lens. Because V3 is 30 plus 30 centimeters. Okay. Is it clear, guys? So this is all about the lens combination. So next class we'll see how the refraction takes place through prism. So prism followed by optical instruments. So maximum 3 more classes we should be done. Okay. So I'm hoping that there is no doubt from today's class. Right?
No doubt, sir.
Okay. Okay, wind up. I'll see you all tomorrow.
Sir, when will offline classes start, sir?
Yarra.
The Vishnu, sir.
Hey, is it in my hands?
I know, sir. Is it
You're
possible
following-
for two students,
You're
sir?
following news. You're following. Illa, I don't know what to say. You're following news.
Yes,
It's
sir. I'm
clearly
following.
indicated. Yeah, correct. Then coaching news, coaching classes are not supposed to happen. Correct.
Sir. Yes,
So
sir.
I'm taking special classes for a school also. School itself is running online. Then what do you want me to do? I do anything against government orders, I'll get a notice. And who can face all those troubles? Class now
Okay.
follow, no? Recordings are given, follow it, no? What is there to do with offline or online? Just concentrate. You know my face, I know your face.
Fine, sir.
What is needed, then attend, yeah. So just a minute, guys, don't log off. See, tomorrow I have an important meeting in a school, okay? So I'm not sure if I can be in a position to handle it. So link will be shared. I'll anyways put this message in group also, but link will be shared. So whether I'll be able to handle class or not, I can tell you only 1 hour before. Okay, please have this in mind. That purely depends on when that meeting is getting over. I'm just keeping you all posted. Okay.
Okay, sir.
Okay. Thank you.
Thank you, sir.
Thank you, sir.